So, so today my topic is on design and detailing of the retaining wall. So it's a unit one title. So design and detailing of retaining wall. So generally, so what is retaining wall? So retaining wall are usually built to hold the back soil mass. However, the retaining wall also constructing for the aesthetic landscaping purposes to resist the sliding of the soil. So retaining wall has been constructed for the purposes only. So retaining wall classified into totally nearly six types. So the first one is a gravity retaining wall. Okay. So then counterfort retaining wall. So likewise, retaining wall has been classified cantilever retaining wall. So these are the basic one for nowadays widely practicing. So other than that, also another three more types are also available. So generally, it means that the basic definition for retaining wall have to resist the soil uh, without any form of sliding. So that is the exact definition for this retaining wall. Then, so how it hold the soil at the background of the before constructing the this wall has been constructing to hold the soil at the back. So there are two types of pressure may be exerted into the soil. One is passive pressure and another one is active pressure. One is one of the pressure was acted towards the soil and another one is acted against the soil. So those two things will happen in a retaining wall structure. So it have the component of the retaining structures are drainage hole, toe end, base slab, shear key, heel end, then another one is stem, then another thing is backfill. Backfill is nothing but the soil which we can retain. That one is called as backfill. Then heel slab is on the side of backfill side. Then stem which is resists the soil into the sliding. Then key is provided when the when it does not resist the shear. Shear K has been provided at the bottom. Then this side is the base slab. The total slab is called base slab. Then toe end is the front side. And drainage hole will be uh, given to uh, allow the water to pass into the without getting drained into the soil side. And then batter, this one is the batter. So these are all the components of the retaining wall structure. Then there's the photos or images which shows that we can see this type of retaining wall in many places. This retaining wall has been uh, more evenly we can see in a hilly area to resist the sliding of the soil. So these are the images then. So first it's so these are the classifications comes under the retaining wall. So first one is gravity wall masonry, plain concrete, cantilever retaining wall, that is RCC structure, that is in the form of T and L, then counterfort retaining wall, then buttress wall RCC. So generally these are the main classification we have in the type of retaining wall. So cantilever retaining wall is designed up to the height of 6 meter. When the height of the wall will exceed over the 6 meter, we move to the counterfort retaining wall with some support of counterfort, which will be located at the back side, at the side of the soil. There is some support will be provided at the end at the equal interval of 3 meter. It will resist and it will oppose the against the sliding of soil. Okay, so these are the classifications has been made. So these are the drawing picture which shows the how the retaining wall will look like. So first thing is gravity retaining wall. So the next one is T-shaped retaining wall, then L-shaped retaining wall, then counterfort retaining wall with the counterforts, then buttress retaining wall. When a counterfort is provided at the side of soil, it is called counterfort. When it is provided opposite to the backfill, that it is called buttress. So buttress retaining wall, counterfort retaining wall. So this is the general classification about this retaining wall structure. Then earth pressure, majorly there are two types of earth pressure has been accepted in the soil. One is active earth pressure, which is from the side of the, which is acting towards the side of the soil. and another one passive pressure which is acted against the soil pressure. So that is called the passive pressure. These two types of pressure has been created in the soil very eventually. So earth pressure is the pressure excreted by the retaining material. So what kind of retaining material that we have been used in to for the construction of wall? So majorly soil has used as a retaining material. So some may so liquid storage structure has been also constructed, but we may some category we may say that there is a retaining wall. So other than that of we says that to hold the soil at the mm, by with the help of retaining wall. So the type of earth pressure which will be acted in soil that are active earth pressure and passive earth pressure. Active earth pressure tends to deflect the wall from the backfill side. It create the deflection at the side of the backfill. Overly, it will get deflection like this. Then passive earth pressure will hold the pressure and it will be acting against the soil backfill side. So that is called passive earth pressure. Then factors affecting the earth pressure are earth pressure depends upon the backfill. So what the type of backfill will be stored at the back side of the wall, the height of the wall, then soil condition. Soil condition, the different side of soil condition has been we can construct a retaining wall based on the different soil condition. First one is dry leveled backfill, next moist leveled backfill, then submerged level backfill, then leveled backfill with uniform surcharge, then backfill with sloping surface. So these are the soil condition we are generally providing the backfills. Then analyzing the backfill, how to analyzing the backfill, how to find out the maximum pressure at the height. So that's a formula that has been given, that pressure intensity, that is press P, then Ka into gamma into H. So it's a formula that a Ka, which is nothing but coefficient of active earth pressure. So Ka, which denotes coefficient of active earth pressure, Kp, which denotes that the coefficient of passive earth pressure, then gamma, which says the density of the soil, then H is denoted as the height. So height, capital H, there is some difference in a capital H and small h. Capital H is nothing but stem height. Then this one is the height from above the ground level. So this is the formula has been derived that to finding the maximum pressure intensity which is happened due to the soil. Okay, the bending moment has been find out by using the formula m into that is passive earth pressure into height divided by 3. Then total pressure also exerted, then moment. So based on the bending moment and shear forces acting on the wall, then only we provide the reinforcement detailing based on these factors. Okay. So that's a thing that has been explained the notations, how the notation has been given as Ka is equal to coefficient of active earth pressure, then Kp is nothing but a coefficient of passive earth pressure, then gamma is density of or backfill unit weight. So this is the thing. So how the backfill with sloping surfaces is possible. Then stability coefficient. The stability coefficient required for the retaining wall. So the following condition may be satisfied with for the stability. So as per the Coral IS 456/2000, the retaining wall should not overturn when a overweight will upload in any side of the retaining wall structure. It should not get overturned and it should not get sliding of due to the pressure of the soil, and it should not subside. That is, maximum pressure at the toe should not exceed the safe bearing capacity of the soil under this condition. There must be some of the safe bearing capacity. We know that safe bearing capacity of the soil will be known one. We can test it based on the safe bearing capacity. Then this is the sliding against the overturning. When this pressure excreted in the side of the soil, it will get overturning. Then this one is sliding, the movement of wall, that is called sliding. So how to resist the wall from the sliding, which is divided by the horizontal force causes due to this sliding. Then these all the factors will enlisted in a cantilever retaining wall, we go for with the shear key. While we are going with the shear key, it can resist all the kinds of the failure whichever acted in a retaining wall. So there must be some condition and criteria has been given for the design of shear key. So this is the maximum, how the maximum pressure and what's basically the triangle has been listed for finding the pressure distribution in a passive side and active side. So P minimum is maximum at the side of toe slab, then P pressure is minimum at the side of the backfill. So this centroid has been found out by using the formula. It's a triangle. Then the centroid has been found out by using the formula h divided by 3. That is entire height divided by 3 is the maximum pressure point. Okay. So this is the formula for finding the maximum pressure and minimum pressure. P maximum, P minimum. P minimum equal to sum of W. That is sum of weight divided by this weight can be calculated by using the stability calculation method. Sum of W divided by B into 1 minus 6E divided by B, which is greater than 0. Then SBC will be the safe against the this all condition. We go with the, it does not go with the, when the wall will not get sliding, it does not go for the we does not go for the shear key providing. Okay, so this is the depth of the foundation. How to find out the depth of the foundation? The depth of the foundation will derive from the geotechnical engineering. The formula is called as a ranking formula. The ranking formula is used for designing the depth of the foundation. So at what depth the foundation will possible for the given height of the retaining wall. Then this zone is the T-shaped wall. So the stem, what is the width provided for the stem? What is the width provided for the base slab? And what is the thickness provided for the base slab? Then toe projection. So these are all the data has been entered. Okay, so all the section will be comes under the balanced section or under reinforced section. Then find the steel. So MU or within the limit or over the limit. So these are the data has been find out in the design of the cantilever retaining wall. Okay, thank you.